Okay, our new stuff for week 3. We're going to start with order and terms. So this is one of those other topics where I am mostly lecturing in a way that may or may not be the same based on your personal math history. So if you have seen PEMDAS, parentheses, exponents, multiply, divide, add, subtract, it's a way to remember the order of operations. Maybe somebody taught this to you well, or maybe they taught this to you terribly. Right? I'm going to spend a few minutes that if it was taught to you terribly, then let's fix that. And by the way, I happen to know that's true for at least one person, because that's part of why I made you show your work earlier, so I know how fast to go now. Okay, so I'm going to take this thing and put it on the Jamboard. A little mouse cursor showing. I'm going to get rid of those things. Okay, I definitely think we want a clean Jamboard today. So which of these is right? Some people will say if I'm doing 8 divided by 4 times 2, that I should do the 4 times 2 first, because M comes before D in PEMDAS. Multiply is earlier than divide. Or other people will say I need to start with the 8 divided by 4 part first, because we're supposed to work from left to right. So if you think the top one is correct, then use your reaction raise hand thing in Zoom. And if you think your bottom one is right, use your reaction raise hand thing in Zoom. And very few people overall raise your hands, because most of you are too cautious. Okay, hands down. It is often like an even split based on what people think. It was about that way just now. And it's actually the second one. So let's talk about that. So the second is correct. Multiplication and division have equal priority and should be done left to right. And addition and subtraction also have equal priority. So one thing we need to do when fixing PEMDAS is to treat those as equal. So if I was showing PEMDAS to people for the first time, I might be kind of odd and write it parentheses, exponents, and then multiplication and division together, and then addition and subtraction together, or something like that. Maybe I want to be really odd and say, oh, let's put parentheses around these things to show that they are one group. No one actually does that, but in your brain have something that says this is one item, this is one item. And if all that's left is that kind of thing, only multiplying and dividing, or only addition and subtraction, then you go left to right. It's also true that PEMDAS is broken in another way, that fraction bars are grouping symbols. Anything you write with a fraction bar, I can also write with a division symbol in parentheses. So it really should be that fraction bars are in there also. So if I was to write it correctly, it would again be something like that, but no one ever does that. You should not do that. I am not recommending it, but in your brain, have the idea that parentheses and fraction bars are one kind of thing. Exponents are one kind of thing. Multiplying and dividing is one kind of thing, and addition and subtraction is a fourth kind of thing. The other problem with PEMDAS is that there's something better. So we're now going to talk about terms. You have to know PEMDAS a little bit. I am lying when I'm saying that, or implying that terms can replace PEMDAS. They can't, but terms is the thing that your brain should think about more. So a term is a portion of an expression that's separated from the equal sign only by adding and subtracting. And I'm going to take something fairly complicated and analyze it like I'm dissecting it. So here we have an expression, which I will make bigger. And I'm going to start at the far left side and amble along until I get a addition or subtraction that's not inside parentheses. So blah, 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 blah. Here we go. So that is breaking apart this expression into terms. And then I keep going, and that was the only one. So for this particular thing, we have two terms and then a plus that's separating them. Is everyone okay just with my jargon so far, even if it's new to you? So the magic happens because each of those terms is completely independent until our last step of addition and subtraction. So I can even make like a Mad Libs fill in the blank template kind of shape here. And think about these two pieces, these two terms separately. So for the one on the left, 4 plus 2, I have to do first as parentheses. So this becomes 6 divided by 3, and 6 divided by 3 is 2. For the second term, 2 times itself is 4. So this is 8 times 4, and 8 times 4 is 32. And then at the end, I'm going to add up my terms. 2 plus 32 is 34. And the reason you need to know this is that these expressions will pretty easily get too long for our brains to be happy just thinking about PEMDAS. It's a completely normal thing for somebody to look at something like 47 and just sort of have their brain shut down because no one has taught you about terms, and so you weren't sure what else to do. If all I know is PEMDAS, then when someone gives me this, it's like, But this is actually an easy problem. So let's go through. How far do I have to move before I get to the end of my first term?
Right there.
Right there, right? There's a plus or a minus outside parentheses. Okay, where's the second term going to end?
The 2 squared.
Right there, right? And then the 5 is its own term. So I can just right away, before I know anything else, and make my shape. And these 3 terms are completely independent things. Suddenly this is looking like 3 easy problems instead of 1 nightmare. So I don't know about you, but I'm just going to put the 5 in its spot because, hey, it's already done. Okay, half times 4 times 5. So this is all multiplying. We just go left to right. Half of 4 is 2. 2 times 5 is 10. For the middle term, 9 minus 1 is 8. And I might as well do my 2 times itself is 4. Now this is all multiplying and dividing, so I'm going left to right. 3 times 8 is 24. 24 divided by 4 is 6. That's still a 10 over there. 10 minus 6 is 4, plus 5 more is 9. Ready to do one on your own? Let me set it up and then I'll pause the recording. So first, before I pause it, stare at this and tell me how many terms there are before we actually solve it.
It'd be 4.
Okay, how big is the first one?
It's up until 11 plus 8 times 2. That would be the first term. Or,
This is 2 terms. 11 is its own term. 8 times
Thank
2
you.
is the term.
mhm,
What's the next one?
up until 14 divided by 7.
Okay. The next one?
Up until 19 minus 4 in parentheses divided by 3.
And then that's the last one. Everyone agree? So
Yeah.
actually 5 different terms. Okay, I'm gonna pause the recording, work on this. If you're watching after the class, then solve it before, or hit pause now and then see if you got it right. Okay, again, I'm going to make my shape. Usually 3 lines is all it takes. Doesn't matter which ones I do first, but since none of them are leaping out as being done except the 11, I'll start on the left. So 11 is just 11. 8 times 2 is 16. 14 divided by 7 is 2. 19 minus 4 is 15. And then 15 divided by 3 is 5. And I don't need this whole bottom one. Then 90 divided by 3 times itself. 3 times itself is 9. So that's just 10. So 11 plus 16 gets me up to 27. Down 2 is 25. Plus 5 is 30. Minus 10 is 20. Did I do all that correct?
Yes.
Okay, give yourself a pat on the back if you did that right. As a side note, that nice calculator can do this all. So we are not having you do this because doing this kind of problem itself is important. We're having you do this for a couple other reasons. One is that if you were to take an algebra class, then if you put a bunch of X's in, then you can't have your calculator do this, right? The calculator only works if everything is a number. The other thing is that we want you to be able to look at when terms are being used in real life. This formula we had earlier about metabolism based on height and weight and age and stuff, if you notice, it's 4 different terms. The multiplying is going to happen first before the adding and subtracting, even if I left out these parenthesis sets. I don't need these parentheses. The parentheses are only there to help my eyes see that when I was doing this formula, then the weight was 1 term, the height was 1 term, and the age was 1 term. And it kind of makes sense the way people's bodies work, that those are 3 independent things, and you just put the numbers together at the end. So now you know about terms, you can notice them when they happen in real life and say, hey, yay, okay. So that was the terms, and we're pretty much done with that. There's more practice. Remember that you can cancel factors, but not terms. When there's a plus in the numerator or denominator, there's no canceling happening. It's only when we're multiplying fractions that we can cancel. And yeah, if you have the other book, there's the other extra homework. Okay, our next topic is variables and negatives. And your Math 52 textbook goes into this a lot. I'm going to share that window again because I want to point out something. So if I go to page 71, then they're going to do some things with grouping symbols and terms like we just did. And then starting on section 3.2, they do this kind of nice thing. It's one of the better sections for this book actually explaining something, where we'll use negatives as red dots and positives as blue dots, and we can see positives and negatives canceling out, making little circles and things like that. So the textbook does a pretty good job of explaining how to do something like -3 plus 6. On the other hand, dots aren't for everyone. The other classic way to think about negative and positive is the number line. And it's kind of sad that they don't have number lines here. They just love their dots. So let's talk a little bit about number lines. Okay, if I take a number line and wanted to do that same problem, -3 plus 6, then it makes more of a sense of motion. I'm going to take my number line. I'm going to start at the -3 spot. I'm adding a positive number, so I'm going to go to the right. So 1, 2, 3, 4, 5, 6, and I end up at +3, right? That looks a lot different than the one that the textbook just did. Let me go back and grab that. Okay, so that's the way the textbook explains it. -3 is 3 negative dots. I IOUs to somebody, I owe you $3. Then when I get paid, I have $6 that are positive. 3 of them will go away with my debt to pay off my friend. And then 3 of them are left, so I can go shopping or something like that. Both work. Most people think one of these pictures is a lot better than the other. So you are allowed to be prejudiced, but understand both pictures so that if you're working with somebody else and their brain likes the other kind of image, then you can speak their language too.
I have a quick question.
Sure.
If these are on the graded homework that we have to do you want us to draw the circles or the graph?
No,
Okay,
but we'll look at the turn-in problems when we're done.
okay.
Okay, back to my quick lecture. Keep interrupting me. We're doing great. So decimals, fractions, you can put them on number lines also. 2.8 would just be that, oh, it's not that I owe somebody $2 starting at 0, 1, 2. I have to go almost all the way to 3. So -2.8 is less than 2. Even though it might look like it's bigger. It's bigger as a debt. And 3.5 would be if I go up 3 and then I go up another half. I could write this as 3.5 just as well. There's nothing special about fractions versus decimals and so on and so forth. Hopefully that's reviewed. What I want to encourage you to do is tell yourself stories. When you're working with these positive and negative problems, then they become much simpler. And especially if you have kids and want to be teaching your kids about this in school, if you talk about stories of what's happening in your head. So 30 plus -12, make up your own story. Here's just one possibility. I'm holding $30 in my hand. I'm going shopping. I know I owe my friend $12. A debt of 12 has been added. So in my mind, I have to plan my shopping trip as if I had only $18 because I have to set aside the 12 for my friend. So that's what we mean by 30 plus a debt of 12 is 18 or something like that. If I had 18 minus -12, that would be a slightly different story. I'm about to go shopping to spend $18 and I owe my friend $12. I have this debt of 12. But my friend says, never mind the debt. It's been 7 years anyway, just keep the silly $12. So the $12 I've been carrying around in my wallet for almost a decade, now I get to spend it. So I have not only the 18, that I was ready to spend, but the $12 I had set aside, so I have $30 to spend. I'm canceling out a debt of $12, something like that. Some people like money because we deal with money in real life, so it seems natural. Some people like altitude. I'm hiking up and down Spencer Butte. Some people like time. I'm going forward or backwards watching a movie. So whatever kind of story works for you. Once you have that kind of story, then again, the story is nice, but try and also have a number line that works. Number line isn't your thing, then again, know how this works for when your teacher is doing it, like right now, or maybe your kids will like it, or your study partner. I'm starting at 4. I have to go back by 6 in the takeaway direction. 1, 2, 3, 4, 5, 6. So I'm at the -6. Now I'm going to add 3 more debt. So another 1, 2, 3. But now I'm removing a debt of 10. The $10 I had set aside under my mattress for Rick, I can now spend. He says, never mind about that. He doesn't want smelly money. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we're going to go down to the small direction of 3.5. 1, 2, 3.5 more, and I wind up at 1.5. So whether it's stories of money or stories of hiking up and down, or jumping back and forth left and right on a number line, or drawing lots of blue and red circles, right? Whatever works for you, have some way to make sense of this. As before, calculators do this fine. It's not like where anyone is ever going to really care that you can do something that looks like this in your head. You could always put on a calculator if you're in a stressful situation and don't want to make a mental mistake, but we're training your brain for other things. 2 more little tidbits. Are we ready to move on? Okay, a negative of a negative is a positive. You've probably heard that. When we're multiplying 2 negatives, it's a positive number. So let's figure out why. I need a brave volunteer who can stand up and show us them walking with his or her webcam.
You want to see one of us walk?
Yes, I'm going to have you walk.
All right, I'll do it.
Okay, so turn on your webcam. Thank you. So you want to kind of stand so that you are in the middle of your picture.
All right, ready.
I'm going to see if I can focus you. If I
Go
pin,
on the walk.
is everyone? Nope, remove pin. What's happening? There you are. Okay. But now you're not pinned. Okay, so I don't want your webcam walking with you, though. So I want it to be like people are looking at you in the front of the room where your webcam is back farther. Can you do that for me?
Do you want me to like place my webcam?
Yeah,
Like,
place your webcam and then take a few steps back.
got it, got it, got it.
Okay, thank you. So stand in the middle and then turn and face what looks like your camera's positive direction on the number line. So your left. Okay, if Dawson wants to model +3 for us, how would he do that?
Take 3 steps forward.
Okay, show us that.
So you want to go forward, right? 1, 2, 3.
Amazing. Okay, so go back to reset, go back to 0 on the number line. If he wants to show us -3, what would he do?
I'll go backwards 3.
So take 3 backward steps. Hooray. Okay, your acting career is secure. Go back to 0 again. You're not done, don't worry. If he wants to do -3 in a totally different way without backward steps, what could he do?
Go to my left. Right?
Show us. No, that's off in some other direction. You need to wind up at -3 on the number line,
I need to be a -3 on the number line.
right? You went to +3, you went to -3. We want some other way for you to be doing -3 without backwards steps.
He would just turn around and walk
Yes,
forward
turn
3.
around and then
It's a good idea. Walk forward or backwards?
now you're gonna walk forward, right? So you wind up at -3. So turning around and then walking counts as a negative number. Everyone with us so far? Okay, we're almost done. So go back to 0, 1 last time. Face positive, because that's how we always start you. And now do both negative things. Do the turning around and then backward steps. Oh, you forgot the turning around.
Well, I was gonna do the normal negative first, but all right. So I turn around.
Turn around. Whoop, nope, not forward steps. Turn around and backward steps. Okay. Wasn't quite as smooth as his previous acting, but everyone see if he turns around and does backward steps, he winds up at the +3 spot. The negative and the negative kind of cancel out and make the positive happen. Okay, hooray! Wonderful, thank you, that was great.
No problem.
Some terms nobody is willing to act out and I have to get my Lego people out and it just doesn't work as well. Okay, share my screen again. So I try and describe that in words here about our volunteer and so on, but now you have seen it really in real life and even better. Again, some people don't like number lines. They think about a balloon that's falling down next to a cliff. And then if you run the film backwards, it looks like the balloon is going up or something like that. There's several ways to think of two negatives happening at once to make a positive, but whatever works for you. Okay, last, if we think about 10 minus x, if we put in x equals 20, the answer is -10. If we put in x is -20, the answer is +30. Everyone okay with both of those things? So if I were to ask you, is 10 minus x positive or negative? There isn't an answer. That's not a meaningful question. It depends on what we plug in. And in fact, I'm only distracting you with a 10 minus. If I just have x, x is not positive or negative. It depends on what you plug in, right? If I put in a positive number, x is positive. If I put in a negative number, x is negative. So if you're moving on to something with algebra, then this is going to mess you up once, and then you will remember today, and you will be all better for the rest of your life. So variables aren't negative or positive. It depends on what you plug into them. And there's a little side note of it. Sometimes in elementary school, they use these little floating minuses, but we don't anymore because of that. Okay, let's look at their 10 exercises. Doubling 2/3. Fractions times a whole number. So this is old fraction stuff. Did I not fix things? That looks like my fraction. Oh, it's just because of those. Okay. So this is stuff you can do. 10 everyone will hate, but you can figure it out. And then if you want to practice with the order and terms, then just keep reloading the page and look at the answer for G. So that will give you some practice there. But the 10 exercises don't even have a lot on the terms. So don't spend time on number 10. Try it, ask for help if you don't see the trick. Okay, back to our thing. So we've done order and terms. We've done variables and negatives. There is a playground called sorting word problems. When the textbook asks you in the beginning of chapter 4 about keeping in mind what types of problems use which arithmetic operations, then they're trying to get you to think about things like this. So this is asking you, here are my pictures of different types of word problems and what's happening. If I'm adding 2, then I am putting more things on the edge. If I am selecting some out of a bunch, then I'll cross them out and have happy and sad faces and so on. Your pictures mentally will not be the same as my pictures. So try and work out what pictures make sense to you. And then at the bottom, there's some word problems that I'm not asking anybody to solve, but just circle which operation is being used in this word problem. And for some of them, there's more than one right answer. So there's no way to turn this in. This is just what I'm calling a playground in the playground section with the kid on the playground. But if you're stuck with the beginning of chapter 4, look at this picture and make your version of this picture. So that's why there's that link right here. Okay, we're about to change topics. Everyone okay? Questions on what we just did with order and terms and variables and negatives? Okay, onward. So for temperature, temperature is just an excuse to plug in numbers for your textbook. Here's an easy formula, plug something in and get something out. I'm going to talk a little bit more about the temperature because you are well-educated people that deserve to know this. First, I am sharing not only the most popular formula to go from Celsius to Fahrenheit or from Fahrenheit to Celsius, but there's 2 others that you might, for some reason, like. The first just replaces the 1.8 with 9/5 if it's multiplying, or times 5/9 if we're flipping to avoid dividing. Some people don't mind the fractions. Most people, because of calculators, like the decimal version of the formula above and will never use the second version. Then the last one, somebody named Robert Warren realized, oh, I can make them look almost the same. They both have a plus. They both have a minus. It's only that when I have F, I need a 5/9, or C, I have a 9/5. So if you were working with maybe a kid that's memorizing these for some reason in school for the first time, this might be the easiest one to memorize if you had to memorize them. But in our class, you can use your notes on the final. No one has to memorize these. Everybody just uses the top one for each case. So let's put those on the Jamboard and ignore all the rest of it, which is just needlessly confusing. Okay, so if I'm doing problem 87, I am starting with a temperature in Celsius. Which one of these 2 formulas starts with Celsius and dumps out Fahrenheit?
Equation on the right.
Yeah.
This one, okay. So the letter by itself is sort of like the output spot on a machine, right? It's like the vending machine where things get dumped out at you at the bottom. All this stuff here is what happens inside the machine to make the process happen. So if we want to dump out Fahrenheit, then this is the one where we put in Celsius. So we're going to say it's 1.8 times 39 plus 32, whatever that is. $102.2. Everyone okay with that? Should we do the second problem where you put in the Fahrenheit and get out the Celsius? No one is saying to. Okay, so the same thing, plug in the number, first subtract, then divide. Your calculator can do this for you. And you get out your answers. So that's all they care about with temperature is can you plug in something in the middle of the equation and dump out something on the side. How did this work, by the way? Why did we get these weird things? So what happened was that everyone has seen a protractor that's shaped like 180 degrees. It's been a long time since I've used one, but you know what I'm talking about when I say a protractor? If not, then I can try and be dangerous and do a web search while people are watching and I'm being recorded. Yeah, these gizmos, right? So when Gabriel Fahrenheit was inventing things, then he said, I want to market thermometers to make money, and let's shape them like protractors. So on one side, we'll have really cold, and on the other side, we'll have really hot. And then our red thing, instead of being a straight up and down thermometer like we're used to today, will kind of be shaped like that. Everyone picture my bent thermometer. Again, my art skill is not why I'm here. So he took the coldest he could make. And when you mix salts and other chemicals into water, the freezing temperature goes down. That's why we salt the roads in the winter. If something would freeze at 32, you mix chemicals like salt with it, and now it doesn't freeze until 20 instead of 32 or something like that. So at the time of his level of technology, he could get something pretty cold, but not as cold as we can today. And then he also said, okay, when does water boil? That's a good thing for if I'm trying to sell these to people to use in the lab. So water will boil. And so initially, that's what he had set as 0 and 180, was how cold he could make things and water boiling. And then he discovered that when that happened, human body temperature was close to 100, but not really. And so he fudged everything. He said, I still want 180 degrees like a protractor, but let's make this one 212 and this one 32. And then human body temperature will be 100 and everything will work out nice. Unfortunately, his measures of human body temperature were off by a little. It's not 100 on the Fahrenheit scale. And having 180 degrees between when water freezes and boils, we don't care about because none of our thermometers are shaped like protractors anymore. So, and the fact that 0, now we can get colder than 0 pretty easily in a lab, whereas that was as cold as he could get back then. So none of these historical details matter to us. They are just annoying. But that's where we get this odd shift of why does water freeze at 32 and so on. It's because he was trying to market these things. And if I remember the story right, he never did and died poor and was not happy. But oh well, we all know his name, such as fame. Okay, temperature, don't get confused. Use the top formulas, ignore everything else. You know how to do this. Lastly, one-step equations. So I'm assuming you've seen these before, but again, we're going back to the let's try and explain them carefully. And I'm happy to go really slow if we need to, but I will try not to go needlessly slow. So help me achieve that Goldilocks just right balance. So if I want to solve either of these, I can think, hey, wait a minute. Something is attached to y with times 5. So to get y by itself, I need to do the opposite. And the opposite of times 5 is divided by 5. So I'll do that to both sides. And then I will get y is 35 divided by 5, which is 7. Everyone okay with both number 1 and number 2? It doesn't matter which order I have, because when I multiply, the order doesn't matter. 2 times 3, 3 times 2, they are the same. I'm going to now look at this one. How does this work? What exactly is happening anyway? So here I have a picture of a balance scale. And somebody wants to solve 4 times b equals 20. That's what it's saying. I have 4 b's and they weigh the same as 20. Let's do it just because we've been taught to do this. Something is attached to b with times 4. So I need to do a divided by 4 to get b by itself. And then ta-da, b is going to be 5. Everyone okay on the left-hand side of my screen? Okay, what happens in the picture? Where is a divided by 4 in the picture? Where is a 5 in the picture?
Each B weight.
Each b will end up weighing 5. That's true. Where's the divided by 4?
Because there are 4 Bs on the scale.
There's 4 things on the left-hand side of the scale, yes. I also want there to be 4 things on the right-hand side of the scale. If I draw that, then what I'm saying is that 1b is going to be the same as 1/4 of 20. Okay, everyone see the divided by 4 on both sides now? So you never have to draw pictures. This is not an art class, but you should be able to follow along and see why it works, that you can do the same thing to both sides of the equation. Let's do the next one with divided by. You know how to do this. If I say p divided by 6 equals 8, something is stuck on with divided by 6. The opposite is times 6. So I'll do a times 6 to both sides. P is now by itself. 6 times 8 is 48. Everyone good with that? If I have my scale, then it's saying that 1/6 of a pizza, there is my 1/6 of a pizza, has whatever, 8 grams, 8 pieces of pepperoni on it. I'm not sure what the 8 is counting, but 8 somethings. So where is my times 6 on both sides? Just like before, if that's the hard thing, think about the finished step first. It might be easier to say, where is the whole p in the 48? My hint is, what do you think P stands for?
I like the story where you said that it was the number of pepperonis. So on the right-hand side, it's 8 pepperonis on that one slice. On the left-hand side, it would be the total number of pepperonis on the entire pizza.
Yes, so P was the whole pizza. Okay, so if I want times 6, I'm saying to my friends, wait a minute, I just passed out slices to you. I need them back for a Kodak moment. Let's put all of our slices of pizza back on the tray for just a moment. I'm making 6 copies of my slice. That's the times 6 there. And similarly, the times 6 on the other side is that I'm making 6 copies of that 8. So now I have 8s all over the place here. 8, whoops, 8, 8, 8, 8, 8, right? And all of that together is 48. And so all of this together is also 48. Okay, once again, you never have to draw balance scales. I am not demonstrating how you should mimic this to solve them, but you should understand what's happening so that when you do the things you've already been taught, let's multiply both sides by 6, then, you know, why does it work? Now you can see it working. Okay, the last bit is first a reminder, do every step on its own line. If you try and do everything in one line, then that doesn't work as well. It can work okay if you are very colorful, but as soon as you don't have colors, you wind up with something that looks like this, and maybe you get the right answer, but 7 weeks from now, when you're studying for the final, this is not going to help you at all. Whereas if you write it one step at a time, it will be great for review. Similarly, if you're working with a partner, this is not going to help whoever's sitting next to you at your study group. They're going to look at that and say, what? But if you do it, each step is its own line, whoever is working with you can see exactly what you're doing. Okay, the last thing is y divided by 3 equals 30. We can do great. This is a one-step equation. All I have to do is say the opposite of divided by 3 is times 3. And then y is by itself, and it's 90. But if I try and do something like this, it doesn't work as well. Now there is no divided by 3. Instead, there's a divided by y. If I try and multiply both sides by 30, I can. I'm allowed to multiply both sides of any equation by 30, but it doesn't make this any better. It just puts 30 in there also. So to do this one, the opposite of divided by y is going to be times y. And then I get 30 is now by itself, because the divided by y times y cancel out, just like divided by 3 times 3 up above. And this side now is 3 times y. And now I can say, because multiplying, it doesn't matter what order I do things. The opposite of times 3 is divided by 3. So let's do that to both sides. And I get y equals 10. And does that seem reasonable? 30 divided by 10 equals 3. Yeah, that looks good. So this is a 2-step equation. If you have divided by and then the letter, or if you have subtracting and then the letter, then it's not a 1-step equation anymore. It's not this nice simple thing that you've done a lot in Math 20. So no one is really going to care about these 2-step equations right now. You're not in an algebra class, you're not in Math 60. But you should know that these are very different creatures. When it's just multiplying, I can switch the order and no one cares. It's exactly the same problem. If I'm adding, I can switch the order and it's the same problem. But if it's dividing or subtracting, then this is one step and this is two steps. So just be aware of that, even if you're only currently asked to do these. And then your 10 problems at the end, I'm lying, I actually will ask you to do some 2 steps now, just for this class. But again, do them with people if they are hard. Okay, we're at 1:20. If you need to go, let's go. But I'm going to do just a repeat of what happens here in your to-do list for stopping the recording. So we're working with 2 textbook chapters. One has the order of operations and negatives. The other has plugging things in and solving one-step equations. The textbook won't ask you about 2-step equations, but I'm wanting you to have a heads up because if you go into Math 60, it will make your life so much easier to be. Look back at the study notes if you want. Do as much homework practice as you need. And then write out a few things nicely. Try the first 2 codes for sure. And if the metabolism is too hard to teach yourself Math 25, that's okay. You're allowed to give up. But I think that it will work and you'll be proud of yourself. Haha, I teach myself college math. Anything else? No. Okay, am I going to see anybody at 5 o'clock today? So far, no one has shown up to the Monday at 5. I will be here, but I'm not going to hang out the whole hour if it's just me. So show up early or send me an email that you're going to show up at 5:30 or something. Otherwise, I'll disappear after 10 minutes if no one's here. But if you happen to be here, great, we'll work together. Okay, yay, we got through it all. Thank you.
Thank you.